Summarize Investigation 1A. So in Investigation 1A, our goal was to understand the relationship between degrees and radian measures and relate the motion of the object around the circle to the graph of the cosine and sine function and solve equations that involve cosine and sine functions. So first thing we really want to make sure was that the unit circle. Unit circle is a circle with radius 1 meter, 1 inches, whatever. So let's say this is the unit circle. And radian, that's the unit circle. Radian is the length from the starting point of this unit circle, which is 1, 0. So let's say we are traveling counterclockwise along the edge of this circle. And the distance that you travel from this starting point along the edge of the circle is the radian. So radian is the length around the circle, right? And that has something to do with angles and degrees. Because, for example, let's say if you travel just a little bit in the first quadrant, like that right there, on that point, then, that random point on the edge of the circle in quadrant 1. If you connect that, if you draw a segment from that point to the center of the circle, it forms an angle. And that angle, we call it central angles. And the partial circle right there, partial circle between those 2 points, we call it arc. Okay? And we know that if you travel around the circle one time and it goes back to the starting points, we know that that's exactly the same as the concept of the circumference. So circumference, we know that it's equal to 2 pi times radius. And since the radius of this unit circle is 1, circumference equals 2 pi times r, which is 2 pi, which is about 6.28. So if you think about the mile, a circle with radius 1 mile, and if you go along the edge of that circle, then you'll be walking or running about 6.28 miles. So that's something we have done first. That's something there that I want you to keep in mind. So let's say now we have a circle, same unit circle, okay? And let's say we go about 30 degrees from the starting point. So it's about 30 degrees. I can use protractors if I want to, but probably 30 degrees is about 2 o'clock-ish, right? So let's say that's 30 degrees. So now, the question is, how long you'll be traveling from the starting point. So now we know if we go around the circle, that's 2 pi, which is the same as you going around 360 degrees. If you travel semicircle, or if you go just a half of the circle, that is the half of 2 pi, so therefore it should be pi. And that's the same as you're traveling kind of like 180 degrees. Okay? Oops. And then if you go 30 degrees, then what would be the radian? So 180 to 30 degrees, I divided by 6. So that's something you want to do for pi. So pi divided by 6 will be pi over 6. If you go to 45 degrees, That's half of a half. Well, if you do 90 degrees, then you go to half of half. So half of 180 degrees, which is pi. So 90 degrees should be half of pi. So 45 degree is half of that 90 degrees. So radian should be half of pi over 2, which is pi fourth. See that? Then how about 215 degrees or 210 degrees? What's the radian of that? We can kind of combine and use these numbers to get the radian, right? So 210 degrees is 180 degrees plus 30 degrees. And I know 180 degrees is pi, 30 degrees is now it's pi sixth. We have to have the common denominator, so I'm going to change the pi in a different form, which is 6 pi over 6, which is pi, which is 1 pi. So 6 divided by 6 is 1. Plus 1 pi over 6, so that should be 7 pi over 6. Just like that, we can keep going. Just like that, we can find out any degrees and radians.